Welcome to qnawire.
Question number 3 wants us to find an equation for the charge Q flowing through a search coil into a magnetic field. A search coil is a tightly wound coil used to measure the magnetic field strength by either rotating it or pulling it quickly out of the field. We're told that the total charge Q on this search coil is equal to the current I times delta T. We want to try and find an expression for Q that involves the number of turns in the coil N, the magnitude of the magnetic field B, and the area of each turn A. By Faraday's law, the induced EMF in a closed loop, such as the ones in this search coil, is equal to minus N times d phi sub B over dt. Now N, as I already stated, is the number of coils in the loop, and d phi is the rate of change of the magnetic flux in the loop. We can also write that as delta phi sub B, and dt is just another way of writing delta t, the change in time. We're told that the flux in the search coil decreases to 0 over the time interval we're measuring. So phi sub B will start out being equal to B times A. That's the initial flux of this coil. And then it'll drop over time to a final flux, phi sub B final, of 0. So based on that information, we know that delta phi sub B, the rate of change of the magnetic flux, is equal to B times A minus 0, or simply B times A. So we can substitute that in to our induced EMF expression up there, and rewrite it as minus NBA over delta T. Now another expression that'll be useful for us in determining the total charge Q is the expression for induced current I. I is equal to the induced EMF divided by the resistance R. We have an expression for the induced EMF above, so we can substitute that into our expression for I here, and rewrite it as minus NBA over delta T times 1 over R. So our final equation for the induced current will be I is equal to minus NBA over R times delta T. Now that we have an equation for the induced current, we can substitute that into our equation for Q. And we find that Q will be equal to minus NBA over R delta T times delta T. We can cancel out the delta T's, and we find that Q is equal to minus NBA over R. Now the next part of this question is asking us to discuss a practical application of a search coil. We can use a search coil in a credit card reader. The way that a credit card works is that there's a magnetic strip on the back of it which stores information with a pattern of magnetization. When the card is swiped, the coil in the card reader has a current induced on it. The strength of the current depends on the way information is encoded into the magnetic strip on the card. So that's how a credit card reader works through utilization of a search coil. Now the next part of this question, the final part I should say, asks about the speed of the swipe of the card through the reader. We're asked if it's necessary to swipe the credit card at just the right speed through the reader in order to make it work. We just determined above the equation for the total charge Q induced in a search coil, and we found that the total charge doesn't depend on the time at which the card is in the reader. So there is no need to swipe the card through at exactly the right speed in order to get a reading from the card.